Just to demonstrate that you can have more than one volume group per Linux system, I'm going to create another VG called VG_safe. And I'm just going to pretend that I need the data stored in this volume group to be very safe, hence the name. Of course, VGs are made up of PVs, so let's create a couple of physical volumes for our new volume group. Again, we'll use our old process here of LVM disk scan, see what's available. SDD and SDE are available, so let's go ahead and create those. Up until this point, we've just been creating one physical volume at a time, but you can give the pvcreate command a list of storage devices. So let's just go ahead and give it both disks at the same time. Okay, let's check out our physical volumes with the pvs command, and it shows we have those two physical volumes that aren't yet assigned to a volume group. Just like we can provide a list of devices to pvcreate, we can also give vgcreate a list of PVs that we want in the volume group. So let's do this. vgcreate, the name, VG_safe, and then the path to our PVs. Now, if we look at the VGs command, we see VG_safe has two physical volumes and no logical volumes at this point because we haven't created any. So let's go ahead and do that now. Let's create a mirrored logical volume. Now, this will ensure that an exact copy of the data will be stored on two different storage devices. And we do this with the lvcreate command, but this time the only slight difference is -m1. So we tell it how many additional copies of our data we want, and we want one additional copy. So that means our data will be stored on two disks or have a total of 2 copies. Again, we'll just give it a size, human readable 5 GB, a name, LV_secrets. Let's pretend this is our company secret data. And then we'll give it the volume group name of VG_safe. So let's look at the LVS command. And actually it kind of scrolled off to the side, but you can see here in this copy sync column that it's currently 18.75. And let me just run this command another time or two here. So that copy %sync column indicates if the mirror is synced or not. Now, if it's at 100%, then all the data is synchronized. So let me run this command again. Okay, at this point, we have exact copies of our data. If you were to replace a failed disk, for example, the mirror would need to resync the data from the existing copy to the new disk. While that copy was in progress, the % would be less than 100. And then when that finished syncing the data to that new device, it would be at 100%. Let's look at the LVs command with the -a option, which stands for all. The logical volume we created is actually RAID 1. So a mirror and RAID 1 are the exact same thing. Anyway, when you create a RAID logical volume, LVM creates a metadata subvolume that is 1 extent in size for every data or parity subvolume in the array. In this example, creating a two-way RAID 1 array results in 2 metadata subvolumes, and those are LV_secrets R meta 0 and LV_secrets R meta 1, and 2 data subvolumes, which are LV_secrets R image 0, as well as R image 1. Now let's look at the map with pvdisplay. pvdisplay-m. At the bottom of your screen, you see that LV_secrets R meta 1 and LV secrets R image 1 reside on the /dev/SDE disks. It's scrolled off the top of your screen, but the output above that is for the dev SDD disk. And that's where the LV secrets R meta 0 and LV secrets R image 0 live. To be clear, we operate on this logical volume using the name we gave it. For example, let's create a file system on that logical volume and mount it, and we'll be using the name that we gave it. So we'll do mkfs-t ext4, and then the path of VG_safe, which is a volume group name, and then the logical volume name that we gave it. Okay, let's create ourselves a mount point here. And let's mount our logical volume. So we write to dev VG_safe LV_secrets and let the logical volume manager handle all the mirroring and all the subvolumes and all that metadata and everything else. We just use this file system like any other, and we use the name that we gave the logical volume manager. So again, anything we were to write in /secrets will actually be written to two underlying storage devices without us having to do anything extra.